Okay guys, so yesterday we spent some time solving cubic equations by graphing. Let's take a look today at solving them algebraically, which I think should be a lot quicker. So it says, how would we solve this equation? So obviously we're going to do some factoring. Either we can factor out a GCF, which we usually can, and we'll usually have a variable in it, or we could think about something like using difference of squares, perhaps, if it's appropriate, which it wouldn't be in the first step anyway. So the first thing I'm going to do is I'm going to see that all of these terms have a GCF of x. I'm going to factor out x. So if we think back to all that time we spent on factoring completely, we have yet another application of factoring completely. So now I'm going to factor the trinomial that's in the parentheses, which is going to be x plus 4 times x plus 2. Now I can split it up. I could say it's possible that x is 0. It's possible that x plus 4 is 0, in which case x is negative 4. And it's possible that x plus 2 is 0, in which case x is negative 2. So my three solutions are going to be negative 4, negative 2, and 0. And that's the same thing we would get on a graph, and if you wanted to check, one way you can check is by using the graph. All right, very similar application here. I'm going to factor out my greatest common factor, which is x. I'm going to factor what's in my parentheses, which is x minus 3 times x minus 1. I'm going to split it up, so I've got x could be 0, x minus 3 could be 0, x minus 1 could be 0. So x could be 0, x could be 3, and x could be positive 1. All right, so let's see what we would want to do here. A couple different things we could do. If you really don't like that negative, you can divide it out. I'm going to factor out negative x squared, which is my GCF. Right? But for a lot of us, we may want to get rid of that negative first. So let's see what that would look like. Right? We get rid of that negative first. Now we're looking at this. Now we factor out x squared. And let's take a look at what the other one would look like. Let's go back here. So this should be x squared times x minus 3. Right? Versus x squared times x minus 3. So let's take a look. When we split this up, I get negative x squared is equal to 0, and x minus 3 equals 0. Well, if negative x squared is equal to 0, I can divide by negative 1, and technically take the square root of both sides, but I mean, just logically, guys, we know if x squared is equal to 0, or negative x squared is equal to 0, that can only be true if x is 0. And here we get x is 3. And if we return to this equation, same stuff. X squared is 0, x minus 3 is 0, so x is 0, or x is 3. So we even touched upon these when we were factoring completely, when we were factoring quadratics. We looked at some cubics. So this shouldn't be like a surprise, but it does fit in with the sequence of, well, we looked at the graphing aspect. Let's see how we can do this more efficiently. Rather than graphing, we can always do it algebraically as well. All right, guys, so there's your now try, and this one should be pretty easy as well. So you can pause it here, and then we're back. I'll factor out x. I can factor x plus 2, x plus 1. Now we can split it up. All right, so I get x can be 0. I get x plus 2 can be 0. I get x plus 1 can be 0. So I get x is 0, x is negative 2, and x is negative 1. So those are going to be my three roots. And again, you can check it either by subbing, those values in, or you can take a look at it on a graph. All right, guys, and there's your homework. Think about how quickly we just did that lesson. So this really should take you no time at all. For number 1, factor out x and then factor what's left. For number 2, I'd recommend factoring out negative 2x and then factor what's left, or maybe factor the negative out first. Number 3, factor out x, and then you've got a difference of 2 squares. Nice and easy. All right, guys, as always, any questions that you have, make sure you reach out to me, and have a very nice weekend.